So today we're going to be working on Intro to Graphing Systems. So we've talked about solving systems of equations in a couple of ways. First of all, we've talked about the fact that systems of equations is when you're looking for a point when two lines cross. And that when we're solving them or getting a solution for them, we're finding that XY point. We've shown you how to solve them algebraically using the substitution method. Today, we're going to show you how to use the graphing method to solve them. Okay, so there's a couple of vocabulary that I'd like to review with you guys first, and that vocabulary is the rate of change and slope. The rate of change is the ratio between a change in x and a change in y on a graph. The slope is a number that describes the steepness or direction of a line. In linear equations, the rate of change will always be the slope. This works for linear equations. Okay, eventually you're going to move on past linear equations and it's going to be a little bit different, but the rate of change is your slope for linear equations. I'm going to give you a few more minutes to copy that down, and then we'll move on to the next part. All right, let's move on to the next page. So let's do graphing equations from lines that are already graphed. Okay, given the equations that we have here, we have x plus y equals 2 and x minus y equals 4. We're going to find the intersection points. The way I'm going to do that is I'm just going to look at the graph here, and I'm going to identify the points where they intersect. Okay, so if I look at my graph, I can clearly see that at 3 and -1 is where they intersect. Okay, remember when we write a point, it's x, then it's y. So our point would then be 3, -1. Now the way we could check this is by plugging this back in, these coordinates back into both equations and making sure that they equal, that when I have x, it's 3, my y is -1. So what I'm going to do is I'm going to plug my x in for y, or my x in for x and my y in for y on this equation and check it. So I'm going to say 3 plus -1 equals 2. Well, 3 plus -1 is 2. 2 equals 2. That tells me that that works for this equation. So now let's try it for this one. I'm going to plug in 3 in for x and -1 in for y. So 3 minus -1 equals 4. All right, whenever I'm subtracting a negative, that's the same thing as adding. 3 plus 1 is 4. 4 equals 4. That means that this point also works here. So this is, in fact, our intersection point. Take a few more seconds to make sure you have that written down. All right, let's go on to our next one. All right, so now I have the equation 2x minus y equals 3 and x plus 2y equals 4. They're both graphed here. So we're going to do the same thing again. We're going to identify what their coordinate is. We're going to substitute to check it. All right. So if I look here, Again, we write our points as x and y. So that's going to be x is 2, y is 1. Now, if I want to check it, again, I'm plugging in for x and for y and making sure that it's equal. So then I have 2 times 2 minus 1 equals 3. 2 times 2 is 4, minus 1 equals 3. 4 times minus 1 is 3, 3 equals 3, so we know it works on this equation. So now I'm going to try it for this one. I'm going to plug in 2 for x, and I'm plugging in 1 for y. So now I have 2 plus 2 times 1 equals 4. 2 times 1 is 2. 2 plus 2 equals 4. So 4 equals 4. So we know it's correct. Once again, for checking, all I'm doing is I'm plugging in my x coordinate into the x on the equation and my y coordinate into the y on the equation. All right, so now I want you guys to write a sentence for me about what you noticed about finding the coordinates if you have the graph already set up for you. What do? Go ahead and write a sentence here for me. Take about 1 minute to do so. All right, hopefully you guys have your sentence written now, and you've talked about how you can find it from a graph that's already made for you and how you can check. Let's move on to the next part. Okay, in this unit, what we're studying is systems of linear equations. Systems of linear equations are when you have 2 or more linear equations to make a system. The solution of those linear systems is an ordered pair where they cross. Take a few minutes to make sure you've got this vocabulary written down on your note page. All right, so let's go on to the next one. So now what I want you to do is solve the system both ways. You're going to solve the system algebraically the way we learned the previous few times. Or, sorry, I didn't resume for you guys. So we're going to either solve it algebraically the way we did some of the previous 2 days on Monday and Tuesday, and we're going to solve it via the graph. So I'm going to do it with you initially, and then the next one you'll do on your own. So looking at the graph, here's our crossing point. Remember that our points always go x, then y. So we're at x is 2 and y is -1. So according to our graph, our result should be 2, -1. So now let's check it by solving it algebraically. So in order to solve this, I first have to convert one of these equations to y equals mx plus b. I'm going to convert this one here. So I'm going to bring it over here so I can convert it. 3x plus 2y equals 4. Center of my equation is the equal sign. I'm going to subtract 3x to get the y by itself. I now have 2y equals 4 minus 3x. I'm going to divide by 2 on both sides. I have y equals 4 divided by 2 is 2 minus 3 halves x. Now I'm going to plug this in for y over here. So now I have negative x plus 3 times the quantity of 2 minus 3 over 2x equals negative 5. I have to get rid of the parentheses using the distributive property, so I'm going to distribute the 3 to both of these. It's going to give me negative x plus 3 times 2 is 6 minus 3 over 1 times 3 over 2x. I can't cross-reduce this at all, so I'm going to just multiply across. So I have negative 6 plus 6 minus 3 times 3 is 9. 1 times 2 is 2. X equals negative 5. Center of my equation is the equal sign. I'm going to combine my like terms, so I'm going to combine negative x and negative 9 halves x. But first I'm going to turn this into a mixed number to help me do that. That's negative 1 over 1x. But since this has 2 at the bottom, I'm going to multiply both the top and bottom by 2, making that 2 over 2x. Well, 2 plus 9 is negative 11 over 2x plus 6 equals negative 5. Now I'm going to subtract 6 from both sides. Negative 5 minus 6 is negative 11 equals negative 11 over 2x. Now to get rid of 11 over 2, I have to multiply by the reciprocal, which is going to be negative 2 over 11. Anything I do to one side, I have to do to the other. Put that over 1. Since it's a negative times a negative, it's going to make a positive. So these are going to cross out. 11 can cross-reduce with 11. Now I have 1 times 2 is 2. 1 times 1 is 1. So I have 2 over 1, which is just plain 2. So that gave me my x value. Now I have to plug my x value back in for x to get my y value. So I'm just going to plug 2 in for my 2 right here. So I'm going to do y equals 2 minus 3 over 2 times 2 over 1. I'm going to cross-reduce those. That gives me negative 3 times 1. So y equals 2 minus negative 3. 2 minus negative 3 is negative 1, so y equals negative 1. So I have x is 2, y equals negative 1. So I can tell you that my point here was correct. It is 2, negative 1. Going to give you a few more seconds to make sure you have all this work written down. All right, So let's go ahead and move to the next slide. I want you guys to practice doing this one on your own. I'm going to give you about 5 minutes to practice it. You're going to solve the systems of equation and identify it on the graph. Go ahead and get started. Whoops, sorry guys, I got that pulled back up. Let's go ahead and go over it. All right, so let's go ahead and go over this problem. So you probably went through and you already went through and noticed that the graph point is somewhere around here. And you notice it's somewhere around 3, -3. So you probably put your point as 3, -3. Remember, x goes first, then y. So then, let's go ahead and solve it algebraically. Since they're already in y equals mx plus b form, I'm just going to set them equal to each other. So I'm going to do 3x minus 12 equals -2x plus 3. Center of my equation is my equal sign. I have to work to get all my x's to one side and all my numbers to the other. So I'm going to take my x's and I'm going to bring them to my left. I'm going to take my numbers, my constants, and I'm going to bring them to my right. So I'm going to start with my x's. This is a -2x. I need to move it to the left. To do so, I'm going to add 2x. Anything I do to one side, I have to do the other. So now I have 5x minus 12 equals 3. Now I have to move my numbers to the other side by adding 12 to both sides. So now I have 5x is equal to 3 plus 12, which is 15. To get x by itself, so I'm going to divide by 5 on both sides. 15 divided by 5 is 3. So we know x is 3, which is what we said here. So far, so good. Now I'm going to plug my 3 back into either of these equations to figure out what y equals. So I'm going to take the top equation, and I'm going to plug 3 back in. So I'm going to say y equals 3 times 3 minus 12. 3 times 3 is 9, so y equals 9 minus 12. 9 minus 12 is equal to -3. So now I have x is 3 and y is -3, which gives me the point 3, -3, which is also the point we identified on the graph. Boom. All right, so then let's go ahead and try our next one. So now I'm going to have you guys start looking at it with you guys starting from the very beginning. So let's talk about the steps where if it's not graphed for you, what steps do I take to graph it to solve it? Well, first thing you have to do is write each equation in y equals mx plus b form, which is our slope-intercept form. Then you're going to graph each equation on the same coordinate plane, then identify the point of each intersection. Then you're going to check it using any kind of algebraic method you can pick. I'm going to give you guys a few minutes to write this down. Then we're going to move on to the next part. All right, so let's move on to the next one. So we're going to follow the steps. Our first step is we have to convert each of these equations equal to y equals mx plus b. So let's start with this equation here. X plus y equals -2. To get it to y equals mx plus b form, or slope-intercept form, I have to move x to the other side. So I'm going to subtract x from this side and subtract x from this side. That gives me the equation y equals -2 minus x. Now I can look at my other one and convert it. So now I have 2x minus 3y equals -9. Center of equation is my equal sign. I'm going to subtract 2x on both sides. So now I have -3y equals -9 minus 2x. Divide by -3. Now I have y equals -9 divided by -3 is going to be +3. -2 divided by -3 is going to make +2/3 x. So now I have both my equations and I'm ready to graph. I'm going to start with this equation here. Whenever I graph, I always start with the y-intercept. So since this is -2, I'm going to go to my y-axis and I'm going to plot a point at -2. Now I'm going to look at my slope, which is -1. That tells me I'm going down 1 over 1. So I'm going to go ahead and draw my line in. Down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. If I wanted to flip it to the other side, I'd actually reverse it because I'm on the other side of the y-axis, and I'd go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And now I've got all my points. Okay, so there's my first line. Now I have to plot my second line. My second line says my y-intercept is 3. So that means I'm starting at 3. Then it says my slope is 2 over 3. That means my rise is 2, my run is 3. So I'm going to go up 2 over 3, up 2 over 3. On the reverse side, because I'm coming versus going, I have to reverse it and go down 2 over 3, down 2 over 3, and then I can draw that line. Now I can look at where my intersection point is. My point of intersect is going to be -3 for x and +1 for y. -3 and +1. If I wanted to double check that, I could set my two equations equal to each other to see. So I'm going to do 3 plus 2 over 3 x equals -2 minus x. I'm going to bring all my x's to the left and all my numbers to the right. So I'm going to add x to both sides. Okay. This is the same thing as saying 1x, so it's now 3 plus 1 and 2/3, or if I wanted to convert this to 3 over 3, it's 5/3 x equals -2. I'm going to subtract 3 from both sides. I now have 5/3 x equals -2 minus 3 is -5. To get rid of 5/3, I have to multiply by the reciprocal, which is 3 over 5. Multiply by the reciprocal on both sides. I now have to make this into a fraction, and I'm going to cross reduce. 5 goes into 5 one time. -1 times 3 is -3. So we know that x is equal to -3. Now to find out what y equals, I'm just going to plug it in to one of my equations, and I'm going to do y equals -2 minus -3. Whenever I'm subtracting a negative, that becomes an addition problem. So y equals -2 plus 3. -2 plus 3 is equal to 1. So I have -3 and 1. So my answer is -3, 1. All right, you guys are going to try the next one now. So I'm going to go ahead and erase my slide, and I want you guys to try this next one. I'm going to give you about 5 minutes. Make sure you follow the steps, convert it into y-intercept form, graph it, and then check it. All right, I'm going to give you 5 minutes. Go ahead and, actually, nope, we're running out of time, so I'm just going to do it with you. Okay, so I'm going to convert this one here. It's 3x plus y equals 11. Center of my equation's equal sign. I'm going to subtract 3x from both sides. That gives me y equals 11 minus 3x for my first equation. My second equation is x minus 2y equals 6. Center of my equation's equal sign. Subtract x from both sides. Then I'm going to divide by negative 2 on both sides. Y is going to equal, well, 6 divided by negative 2 is negative 3. Negative x divided by negative 2 is positive 1/2 x. Now I'm going to go ahead and graph them. I'm going to start with this equation here. My y-intercept is 11. Okay, so that's going to be way too far up for me to be able to graph. There's not enough room on my y-intercept here for me to graph. So now I need to figure out what it is when x is 1. So I'm going to do 11 minus 3 times 1. 11 minus 3 times 1, well, 3 times 1 is 3. 11 minus 3 is going to equal 8. That's still above where I can put it, so now I'm going to try 2. 11 minus 3 times 2 equals 11 minus 6, which is 5. So at 2, we're at 5 for this point. And because my slope is negative 3, that is the same thing as saying 3 over 1, which means my rise is down 3 and my run is over 1. So I'm going to go down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1. So this is my first line here. Now it's time for me to draw my second line, which is negative 3 plus 1/2. Since my y-intercept is negative 3, that's where I'm going to start. I'm going to go down 3. Then I'm going to go to my slope. My slope is 1 over 2, which is the same thing as saying rise 1 over 2. So I'm going to go up 1 over 2, up 1 over 2, up 1 over 2. If I wanted to draw the line on this side, I'd go down 1 over 2, down 1 over 2, down 1 over 2. And now I'm going to draw my line. And you can see our crossing point is right here at 4, negative 1. Now I just need to check it. In order to check it, I'm just going to set the two equations equal to each other. So I'm going to do 11 minus 3x equals negative 3 plus 1/2 x. Center of my equation's equal sign. I'm going to move my x's to the right this time and my numbers to the left. So I'm going to add 3x, add 3x. So now I have 11 equals negative 3 plus that. I could either put 3/2 x, or I could convert it to halves, which is going to put 6 over 6, which would make it 7/2 x. Now I'm going to add 3 to both sides, add 3. That gives me 14 equals 7 over 2x. To get rid of 7 over 2, I have to multiply by the reciprocal, which is 2 over 7. Anything I do to one side, I have to do the other. I can cross-reduce 7 and 14 to be 1 and 2. 2 times 1, 1 and 2. 2 times 2 is 4, so x is equal to 4. Now to find out what y equals, I just need to plug x in. So I'm going to plug x over here. I'm going to do y equals 11 minus 3 times 4. 3 times 4 is 12. So 11 minus 12, which is equal to negative 1. So my y equals negative 1. So I get 4, negative 1 for my points. All right, now that we've finished that, I want you guys to do this final problem as your homework tonight. Go ahead and log out for those of you who are attending via WebEx. Those of you who are listening to the video, I'm going to go ahead and finish that in just a moment. Have a great day, those of you attending WebEx. All right, so let's go over this one. Remember, the first step is that we're going to go ahead and convert it to y equals mx plus b form. So I have negative 2x plus y equals 2. Center of my equation is the equal sign. I'm going to add 2x to both sides. Y equals 2 plus 2x. Then for this one, I'm going to convert it. It's x plus y equals negative 1. Center of my equation is equal sign. Subtract x from both sides. Y equals negative 1 minus x. All right, so let's go ahead and graph. I'm going to start with this one. My y-intercept is negative 1, so my first point is negative 1. Then my slope is negative x, which is the same thing as saying negative 1x, which is the same thing as saying 1 over 1. So my rise is up 1, and my run is over 1. And actually, since it's negative, it's down 1 over 1. So down 1 over 1, 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 up 1 over 1. Because I'm on the other side of the y-axis, I then flip to up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, 1 over 1. So there is my graph for you guys. Sorry, it's not the easiest to draw a straight line with the mouse on the computer. So there's my graph for this equation. So now let's do my graph for this equation. This is 2 plus 2x. So it's going to be 2. 2x is the same thing as saying 2 over 1. So that's up 2 over 1. So up 2 over 1, up 2 over 1. On the reverse side, it's down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. I'm going to draw my line. And my point where it crosses is going to be right here at negative 1 and 0. So it's negative 1 for x and 0 for y. Now I'm going to double check it just by setting them equal to each other. So that's negative 1 minus x equals 2 plus 2x. I'm trying to get all my x's to one side and all my numbers to the other, so I'm going to bring x's to the right, numbers to the left. I'm going to add x to both sides. Now I have negative 1 equals 2 plus 3x. I'm going to subtract 2 from this side, subtract 2 from that side. So negative 1 minus negative 2 is negative 3 equals 3x. Now I'm going to divide by 3 on both sides. Negative divided by positive makes a negative. 3 divided by 3 is negative 1, so my x is negative 1. Now to figure out my solution, I'm just going to plug it into either of my equations. I'll go ahead and plug it into this one, which is y equals 2 plus 2x. So that instead of x, I'm going to plug in negative 1. 2 times negative 1 is negative 2. 2 minus 2 is 0. So y is equal to 0. So we can see our point is negative 1, 0. All right, guys. Now you're going to want to start working on that dilation, similarity, and slope PFA. And I'll see you guys later.